The thin film technology that Qualler is talking about could be the next big thing. California-based Nano Solar is one of the pioneers in this field. Instead of making solar cells on bulky, expensive silicon wafers, the company has developed a light-conducting ink that's spread on a material that looks like foil.
What we've developed are inexpensive techniques based on printing.
Chris Eberspacher is one of the lead researchers.
On your left is a piece of bare metal foil. On your right is a piece of foil that has been coated with a thin semiconductor layer to convert sunlight directly into electricity.
It's thin, flexible, and here's the key. It rolls off the presses in long strips.
What we're headed toward are large non-vacuum printing technologies, and the right mental image is one of a large printing press, for example, like newspaper printing.
Took a sliding interaction. He said it couldn't
work. He is trying to harness those relentless rays. You're saying this is basically the coming out party of solar energy?
I hope so.
Traditional energy sources on a large scale, building a series of dishes concentrating light onto these tiny panels. Feynman says he would need just 12 square kilometers to create 1,000 megawatts of energy at competitive costs. Solar energy is big business here. Solel Industries watched sales soar past the $100 million mark last year. Their technology involves using huge concave mirrors to make steam. Just 2 weeks ago, the Israeli company signed a contract to build the world's biggest solar energy plant in the Mojave Desert in California. More than 1 million mirrors, 600,000 acres, and 550 megawatts of power. Solel won't disclose.
Shoot up. Once that's in can, they'll go shout out.
Than the surface of the sun. Heat so intense it takes only seconds to literally burn a hole through charcoal. 3 seconds turns a brass ball.
We have booster ignition and liftoff of Endeavour on a voyage to view the universe.
Houston now controlling.
Roll program, Houston.
Roger, rolling.
早速入れてみたいと思います。ご覧の通り、エンジンは何事もなく快調に回っています。
エンジンは市販の車を改造しました。まず送り込まれるのは水素です。点火して水素が燃えた直後、水を霧状に噴射します。水素が燃える熱で水は気化して水蒸気になり、爆発的に膨らみます。この力を動力
to making fuel cell technology a reality, to replace the internal combustion engine in your car with a clean, quiet, pollution-free fuel cell engine. Fuel cell-powered cars look just like other cars on the road today, but they are cleaner, quieter, more efficient, and work very differently. When you turn the key, hydrogen and compressed air flow to the fuel cell module, which contains the fuel cell stack. A fuel cell engine consists of the proton exchange membrane, or PEM, fuel cell module, coupled with the systems required in a typical automotive engine. The electricity produced by the fuel cell is delivered to the electric drive system in the vehicle. The drive system converts electrical power into the mechanical energy that drives the wheels of the car. The fuel cell generates electricity that can be used to power a car, truck, bus, or other vehicle for as long as fuel is supplied. The fuel cell is 2 to 3 times more efficient than your gasoline engine and does not create pollution. Additional benefits include increased performance and onboard power, higher reliability, and greater flexibility in vehicle design and engine layout. But how does the fuel cell work? A single PEM fuel cell is made up of 2 plates, 2 electrodes, and 2 thin layers of platinum-based catalyst, separated by a plastic membrane, which, when fed with the fuel, reacts electrochemically to create electricity. Hydrogen from an onboard storage tank and oxygen from air are fed through channels on the plates. Hydrogen flows on one side of the membrane, air on the other. The catalyst splits the hydrogen molecule into protons and electrons. The protons can pass through the membrane. The electrons cannot, and have to pass through an external circuit, creating useful electricity. On the oxygen side of the membrane, the protons and the electrons react with oxygen from the air in the presence of a second catalyst layer, generating water and heat. By stacking together single cells, like slices in a loaf of bread, you make a fuel cell stack to produce the required amount of power. Just like your car, fuel cells need fuel to operate. The Ballard fuel cell uses hydrogen as a fuel, which can be produced in many different ways, and once produced can be stored as a compressed gas or liquid, or in a chemical or metal compound. Different areas of the world will create hydrogen in different ways, depending on economics and available resources. Hydrogen can be delivered to fueling stations by road, barge, rail, or pipeline, or can be made on-site at gas stations. People may one day be able to produce their own hydrogen at home. You can see there are many options available to enable the hydrogen infrastructure to grow. Fueling the vehicle is very similar to the way you refuel your vehicle today, but requires a special sealed connection before the hydrogen can be pumped into the vehicle's storage tanks. It only takes a few minutes to refuel a fuel cell car. And when fueled by hydrogen, a fuel cell emits water and heat and no pollution. Think what this means to the air around us. Now that you understand how the technology works in a fuel cell vehicle,
Mike, an energetic man, has a passion to find a solution for our future energy needs.
Electricity here, it takes the power and runs it through the battery bank down into this device called an electrolyzer. This electrolyzer takes tap water and runs it through a purification system you have here, which is reverse osmosis and deionization. From here it is placed, it runs through another and actually beneficial to the environment. This is the hydrogen fuel cell. This fuel cell is a 6 kilowatt plug power fuel cell that's used in the telecom industry to power
a solid state device. It converts fuel, hydrogen, and oxygen from the air directly into electricity. No combustion.
And be quiet. And of course, with a fuel cell, produces electricity just as long as you provide it with the fuel. This is the fuel cell engine. This incorporates 1,500 separate fuel cells. It's a 275 horsepower unit, 750 volts. Inside the fuel cells here, we combine hydrogen in a compressed gas form and air, the air that you breathe. We create water, and off of that chemical reaction, we tap off the electricity.